Hello there. So last time I read a study and critiqued the study, and as promised, now I'm going to do my own analysis of the data. So let's step into R. Actually, before I do that, let me make one comment. So I mentioned in the previous video that they should have done like a mixed model sort of thing because they have repeated measures. But then later they did an analysis on the aggregated data. Of course, they didn't really say that's what they were doing, but that's what they did. And I don't understand the data. It doesn't make sense to me. So they say there's 36 time points, but then in the data set, they have like 1 through 12. So it's repeated 3 times, and I don't know what the 3 repetitions are. And so because I don't understand what's going on, and because it's not very clear, I'm just going to analyze the aggregated data. So with that, now let's step into R. So I'm requiring the packages that I'm going to use, including the party package, and we'll see why in just a minute. And then I'm going to read in the data here. And then I'm just making sure all the factors that are relevant are factors and getting rid of the variables that I don't need. Now that's actually something that I should probably talk about. So they talked about 2 bad investing strategies. One was repurchasing and the other was disposition, I guess. But then they ended up analyzing like all these different components of those things without actually analyzing. Well, they did actually analyze disposition and repurchase, but they analyzed a bunch of other things too. I don't know why they did that. I suspect it was probably related to p-hacking or whatever. So what I decided to do was actually analyze the variables that they mentioned in the introduction: disposition and repurchase. So I'm going to start by looking at the distribution of all those. And so disposition has a range from negative 0.25 to positive 1. And remember, disposition means the proportion of times they sell profitable stocks minus the proportion of times they sell losing stocks. So apparently, if a stock is winning, it's a bad idea to sell it. So you only sell it after it starts losing, apparently. And then repurchase, and I still don't understand what this variable is, but there's the distribution. And it's how often they repurchase stocks that have fallen in price after the sale minus how often they repurchase stocks that have risen in price. I think they actually have a table 1 in the paper that is supposed to explain those things, but you'll notice right here that this formula for repurchase is the exact same as this formula for disposition, which doesn't make sense. I suspect that was a typo. So because I don't actually know what repurchase is, I'm just guessing. Which is actually kind of frustrating for me because I really like to understand the variables that I'm analyzing when I'm doing data analysis, but it is what it is. And also a final reminder, I am 100% exploring this data set. So we've got some hypotheses about what might be happening with this whole pollution affecting the mood, regret sort of thing. But really they're exploratory research questions. And because I am exploring, I am basically not holding anything back. I'm going to quote-unquote p-hack, although I would call it rough CDA at this point. But I'm going to fish. I'm going to do lots of different things. The difference between what I do and what most people do when they p-hack or go fishing is I'm not relying just on the p-value. I'm going to use plots, and I'm going to use estimates, and I'm going to use all sorts of information to try to make judgments about what's going on here. So with that, let's get into R again. So I'm going to start with the disposition variable. And what I decided to do, because they had so many potential covariates, I decided to and because it was exploratory, I just decided to use a random forest and say, all right, why don't you tell me what the best predictors of disposition are? So if I run that and then look at the estimates, and the variables that show up as the most important are group, consume, which is basically salary. I don't know why they call it consume, and then sex, and then regret. By the way, this strategy that I'm using, if you want to learn more about that, you can see Fife and D'Onofrio 2022, I think it is. I will link a copy of that in the description. And so what I'm going to do is I'm going to choose these 4 variables because everything else is 0 and FlexPlot can only visualize 4 variables at a time anyway. And so now I'm going to build a separate model with those 4 variables in the random forest model. And then I'm going to look at the estimates here. And so I'm not going to worry about this part. So we're only explaining 7% of the variance. There's not much signal in the data. And then if we look at variable importance, group is the biggest predictor, followed by consumption, followed by sex, then regret. And so now my strategy is going to be to try to visualize what's going on. And I like things to line up because it makes it easier to scan your code. And so what I'm going to do is I know group is my biggest and most important predictor, so I'm going to put that in panels, and I'm just going to see whether any of these variables interact with group. And so I'm going to start with regret, and the red line is the random forest model, and it looks like they're all relatively flat, so it doesn't look like regret is really doing anything in this model. And that's why I make that note, fairly weak effect. Let me make this a little bit bigger. And then if we look at sex or gender, we see that there are group differences and they shift a little bit depending on the group. So in the control group, there's very little difference between males and females. In the mosquito coils, there's a fairly large difference, as well as in the straw group. So it looks like there might be an interaction effect between group and sex. And then now if we look at consumption or income, we see possibly an interaction. So the relationship between consumption and disposition for the control group is fairly flat, but it's much steeper in the two pollution groups. All right. So at this point, I know I'm going to model, or at least try to model, interactions between group and sex, as well as between group and consumption. And I'm going to try to evaluate whether regret is an important predictor. But before I do that, my big concern here, because we're dealing with proportions, is I don't know if a linear model is going to work, because it assumes normality. And this is a bounded distribution, meaning it can only go from -1 to +1. And that can be concerning for linear models. So I'm just going to fit a massive model and then look at the residuals and see if that's a problem. So if I look at this plot on the right, the histogram of the residuals, it's bumpy, but you would expect that for a sample size of, let's see, N row D, 113. Not that big of a sample, so the fact that it's fairly symmetric, it's not like super skewed, I'm not worried about that. And then residual dependence plot, there's some bumpiness, but for the most part it's relatively flat, suggesting that we don't have any linearity problems. And it looks like it could be a little heteroscedastic, but I'm not too worried about that because these models tend to be super robust against those. So, but what I'm not seeing is I'm not seeing evidence that we have a really terrible model and we need to shift to a beta distribution or something like that. So I'm going to provisionally move forward with a linear model, just because that makes things easier. And then when I get to the end, when I choose my final model, I'm going to study the residuals again and make sure I'm still safe. So anyway, let's do a model comparison for the interactions. So there were two potential interactions that we could do, and I'll look at the full and the reduced, and then look at the compare fits. And what do we have? So in this plot, so if we look at the predictions between the two, they're like super similar. I mean, the biggest difference I see is in this panel right here for consumption 3 to 4 in females under the control group. But even that's not that big of a difference. So I'm gonna guess that we don't need any interactions. And just to give myself another source of evidence, I'm going to compare those. I don't know why those models weren't the same. I'm going to compare the full and the reduced model, and the AIC smaller is the favored model, so the AIC favors the reduced, so does the BIC, so does the Bayes factor. P-value says there's no difference between the two, and so when there's no difference, you go with a simpler model. R squared, we're only explaining 2% of the variance by adding those extra 2 predictors, and then the adjusted R squared favors the full model. Favors the reduced model. So it seems like we don't need those interactions. And that actually makes things a lot easier. Now let's see if we can get rid of the last 2 variables, sex and regret. Group, consume, sex. That almost sounds like a sentence. Group, as a group, we consumed sex and now we're filled with regret. That's weird. Anyway, I'm going to do a model comparison now and see if I can get rid of those last two. And if I do a compare.fits with sex on the x-axis, we do see differences, slightly bigger than we saw in the last one. And by the way, the reduced model is going to be flat because the reduced model does not have sex in it. And so even though at least right here, when I look at it, it looks like that's a slightly positive slope, but it's not. It's totally flat. And so, but still, we don't see massive differences between the two models. So to me, that suggests that sex isn't that important of a predictor. And now let's go ahead and look at regret, which is like one of the variables of interest for the study. And what do we see? We do see differences in slope. You know, again, regret for the reduced model is going to have a flat slope. And so we do see differences. Maybe there's something there, but of course we only have a sample size of 114, so I'm not optimistic that these statistics are going to favor it. In fact, I've already done this analysis, and I know I'm spoiling the ending, but that's okay. But if we look at the statistics, AIC actually favors the full model. BIC favors the reduced. Bayes factor favors the reduced. P-value favors the reduced. Not massively. There's a difference of 4% of variance explained. Adjusted R-squared favors the reduced. So it's actually, I wouldn't even say we're favoring the reduced. I'm going to change my conclusion and just say it's ambiguous. And so at this point, you could either fail to make a decision, just say, I don't know, it's ambiguous. It's up to you, fair reader. Or you can make a decision and justify that. I'm going to say, no, I don't care about it. Because the Bayes factor says the evidence in favor of the reduced model is 13 times stronger than the evidence in favor of the full model. And the fact that the AIC, I guess it's just the AIC and the adjusted R-squared. So I guess we could even take a vote. So BIC and Bayes factor and p-value favor the reduced model. Although the BIC and the Bayes factor are always going to favor the same model, so maybe that's unfair. But still, I think I'm just going to get rid of it. What am I getting rid of again? Oh, sex and regret. Yeah, no need to regret sex. So we're just going to get rid of both of them. Now for the hypothesis. So so now we know that the best model at this point is group and consumption. And so now we get to actually evaluating the hypothesis, which is what the authors wanted to evaluate, which is, does the different experimental conditions increase the chance that somebody's going to engage in disposition or bad trading practices? And if we fit those two models and then visually compare them, and again, the reduced model is going to be flat because it doesn't allow group as a predictor. And so the red model shows the differences, and they are pretty big differences. So if we do a model comparison, AIC favors the full model, BIC favors the full model, Bayes factor favors it 4-1, p-value favors it. We are adding about 9% R-squared, and then the adjusted R-squared massively bigger in the full model. So yeah, it seems like group makes a difference. So if you are in the experimental condition where they're burning stuff and polluting the air, it's going to affect it. In what way is it going to affect it? So disposition, higher values mean badder, worse trading. And so, yeah, it seems like the two pollution conditions increase the probability that you're going to engage in bad trading behavior. So it supports the author's hypothesis. Yay, one of them. And let's go ahead and study the residuals again. Like I said, I wanted to come back to this just to make sure that nothing's too wonky. And what do we have? We have the residuals. They're bumpy, but for the most part, it's symmetric. We've got our residual dependence plot, which tells us that, I mean, again, it's a little bumpy, but I'm not too worried about that. In fact, let me just zoom in on the residuals and say plot equals residuals. And if I do that, I'm just going to go ahead and make this big so we can focus in on this. So this says, yeah, the heteroscedasticity issues that we had earlier are gone. There's some bumpiness, but it's not massive amounts of bumpiness, so I'm not too worried about that. And it's not like there's a consistent pattern. I guess you could argue that maybe there's a missing quadratic in there, but I seriously doubt it, and with this sample size, I'm not even going to try. So it looks like the fact that we are using proportional data and fitting a linear model to proportional data isn't that problematic, so that's good. Now let's go ahead and visually summarize the results. This is what I call creating visual partitions, where you partition the entire model into kind of independent segments for interpretation purposes. And so if we wanted to visualize the group effect, this is what it looks like. So it seems that being in either of the two pollution conditions does increase your disposition or bad trading practices relative to a control group. So yay for support. And then if we wanted to look at the consumption variable, is that... Yeah, I guess it was consumption. For some reason, I thought it was something else. Anyway, consumption variable. So we see that the more you... And again, this is like income, I think. I think it was like yuan. Yuan, is that how you say it? Like Japanese currency, I believe it is. Anyway, this is how much they spend a month. Maybe in thousands? I don't know. I don't know what yuans... how they compare to the US dollar, which is what I'm familiar with. But maybe this is how many thousands a month they spend. We'll just say that. Let's say this is how many thousands of dollars you spend a month, except it's in yuan. I don't even know if I'm saying that, so I'm going to stop saying that because I feel stupid. Anyway, we see that the more you consume or the more money you spend, the worse your trading behavior gets. Which, I don't know if that makes sense or not. Actually, would think it'd be the opposite. That people from more wealthy families might be more inclined to pay attention to the stock market, but apparently not. Anyway, and then if we wanted to look at the estimates and just kind of pick some things that are interesting, so the model R squared. Well, now that's interesting. That makes me skeptical. Earlier, the estimates for the random forest model, we only explained 7% of the variance. But now we are explaining almost 15% of the variance. That's kind of weird. Okay, now I'm puzzled. I'm going to just include the predictors. Oh, you know what? I think I know why. But just to double check. Okay, yeah. A reminder that R squared is a cross-validated R squared, or what we would call in random forest language, it is out-of-bag R squared. So it is a validation model, not a fitting model. So I would expect the R squared to go down significantly. Okay. Started to worry that I'd mess something up. Okay. So, yeah. Our model R squared, we're almost explaining 15% of the variance. 11% of the variance is attributable to group independent of consumption, and 3% is attributable to consumption independent of group. And then here are the estimates. So on average, 30% of the time they make bad trades, I guess. I don't even remember what this variable is. Anyway. 0.3, 0.43, and 0.49. So it looks like straw has the biggest effect. And then we got these group differences. Yeah, Cohen's d. So the mosquito coils relative to the control is 0.54 Cohen's d. So there's a half standard deviation difference. 0.81 for the straw versus the control. So those are pretty big differences. So it's weird, but apparently having pollution affects your strategy when you're trading on a fictitious stock market. Jeez, I can't talk. And then 0.27, and then a Cohen's d of 0.27 for the two experimental conditions. And then consumption 0.05. So for every $1,000 a month you spend, your bad trading behavior increases 5% since it's a proportion, I guess. Anyway. Whatever. So that right there was the analysis of the disposition variable. Now, let me look at the repurchase variable, which again, I don't understand what this variable is. So I can't speak to that much, but we're going to go ahead and use the same strategy. We're going to use random forest to compute variable importance for each of these variables. So we've got group, age, consume, and sex, and those are the only ones that have a value. So I'm going to group, consume, age, sex in there, run that model, compute these estimates, and the model R squared is 6.6% of the variance explained-ish. And then the biggest predictor again is group, followed by consumption, then age, then sex. So just as before, I'm going to look at the relationship between sex and repurchase, conditional on group, as well as all the other ones. And so for the sex variable, again, possible interaction there between group and sex. And then age, kind of. There's a little bit of a slope and maybe, probably not an interaction though, just a little bit of slope, but not much. And then consumption and age, those slopes seem to be mostly parallel, so I'm going to say possible main effect for that one. So just as we did before, I'm going to build a massive model with all these variables together and then study the residuals. And we find a fairly symmetric normal distribution of the residuals, a little bit plateaukurtic. That's a fun word to say, plateaukurtic, which means it's more spread out than a normal distribution would look. Residual dependence plot, there's a little bit of bendiness, but not much. And then SL plot looks like we have met the assumption of homoscedasticity pretty well. So I think it's okay to continue with model building with linear models. So now I'm going to fit a model with all the main effects and then a sex by group interaction and do a model comparison there. And then visually, so similar. It looks like, yeah, they're making basically the same predictions. And the AIC agrees that they're making the same predictions, or in other words, no. Oh, AIC is actually favoring the full model. BIC is favoring the reduced model. The base factor says the evidence in favor of the reduced model is 3.6 times greater than the evidence in favor of the full model. P-value, on the other hand, says we should accept the full model, R squared, explaining about 5% of the variance. Adjusted R squared also goes with the full model. Again, it's ambiguous, but only because the BIC and the base factor. Everything else says that we should go with the full model. So provisionally, I'm going to go with the full model. So now I'm going to just evaluate the weakest of the three. I think age was the weakest of the three. Let me go back to the random forest. Oh no, it was the second largest. I don't know why I did age first. Oh well. Actually, you know what? I'm going to change the order of this. And I don't know if this will change my results. It might, but we'll see. So, I've got to put age back in there. Age plus group. I do think I should go in order. So if I fit that model, so the only difference between these two models is, oh, that's not what I meant to do. Consume. Okay, the only difference between these two models is the inclusion of... Why did I do age? I meant to do sex. Oh, we can't get rid of sex. Because we just decided that we're going to keep it because it has an interaction effect. So, just kidding. All right. Instead, we're going to look at consumption. Plus age. Okay, I'm getting oriented here. So yes, let's do a model with versus without consumption, but we still have sex, age, and group, and then the interaction. And then I'm going to put consumption on the x-axis. And again, the reduced is flat, as it should be, because the reduced doesn't have consumption as a predictor in there. And then we do see differences. The differences in the actual predictions aren't that large, though. So let's look at a model comparison. So AIC favors the full, BIC favors the reduced, base factor favors the reduced, p-value favors the reduced. R squared, we're only explaining 2% of the variance. Adjusted R squared favors the full. again, it's another situation where it's ambiguous, and this happens a lot when you have small sample sizes, like in this one where it's like 110 or whatever it was. But I'm going to favor getting rid of consumption and moving on. So now I'm going to see if I can get rid of age. So now these models shouldn't have consume in there anymore. So now I'm comparing a model with versus without age. And then, oops, let's see, some variables. Oh, consume, yeah, that shouldn't be there anymore. Plus sex. And then if we look at the two models here, again, the reduced is flat as it should be because age isn't a predictor in the reduced model. And we do see differences, not massive differences, but there are differences, kind of hard to tell from here. Let's do a model comparison. AIC favors the full, BIC favors the reduced, Bayes factor barely favors the reduced. Values of 1 mean it can't tell one way or the other. So it's about as close as you can get. So it's having a hard time telling. P-value is borderline, but would favor the reduced. R squared, we're only adding 3% of the variance. Adjusted R squared, you would say favors the reduced. So it's a bit ambiguous here. Earlier I made the decision to get rid of age. I'm going to go ahead and stick with that just to make things simpler for myself, but it is ambiguous and you might make a different decision. That's totally fine. So final model is going to be now I'm going to fit the final model and visualize the residuals as I did before, and that looks fine. So that's good. The residuals do look a little negatively skewed, but I'm not worried about that. Now also I make a note here that's probably in the wrong place. So final model, note, can't test effective group alone because, oh yeah, so before in the last dependent variable that I used, I did a model comparison where I have group in one model and not group in the other model, and then did that model comparison to see if we need to keep group. And I would like to do that because that's what they hypothesized. They hypothesized that there would be a difference between the groups, but it interacts with sex, and you can't test group in isolation if there's an interaction with group. So, and for the same reason, we can't visualize just group. We have to visualize it with sex because it's an interaction. You can't interpret interaction. You can't interpret main effects in isolation when that main effect also has an interaction. So now if I were to visualize this model, so this is like a visual representation of the sex and group effect. And what are we finding? It seems that females are less affected by pollution. So the straw and the mosquito coil groups aren't all that different from the control group. In other words, it didn't seem to matter. So females were not bothered by the pollution, whereas males were. And males kind of sort of do better overall, at least when you look at the control group. Remember, lower values on repurchase mean that they did better, that they made better financial decisions. So if you just compare the controls, it looks like the males are doing better, but once you add the pollution, the males and females are about the same. So I guess you could just summarize and say males were more affected by pollution than females were. So let me just step back and kind of compare their conclusions to my conclusions. So their conclusions, I guess like the big thing that they wanted to show was that there is some sort of a mediation going on, that pollution affects mood/regret, which then affects your trading behavior. And I found zero evidence of that. It didn't seem like regret was doing anything. And you might say, well, maybe if you had conditioned on the right variables, but I use random forest, which is non-parametric, and it natively detects these interactions. It didn't find any sort of interactions, didn't find any sort of suppressor effects or anything like that. And so it looks like regret just isn't doing anything. So yeah, I guess take-home messages. Some practical, some not. The non-practical is, if you're not experienced in doing stats, probably should avoid doing your own stats, because you make all sorts of mistakes like these authors made. more on a more practical level, I would say just be consistent. Like sometimes they were analyzing repurchase, sometimes they were analyzing PDR or repurchasing behavior and segregating. Just like be consistent. Choose one dependent variable and stick with it. Or if you do investigate all of them, consistently investigate all of them. And then I guess the other caveat is just to make sure you understand the assumptions of models. So I think one of the biggest mistakes they made was analyzing repeated measures data as if they're independent, and that's not a good idea. But when they started doing the analysis where they aggregated it within individuals, then they're fine. So I hope you found this helpful. And I'm interested to get your feedback. Do you like this sort of a thing where I dissect another study and kind of reanalyze it and show how I would do it? And by the way, this is one way. I debated between several different strategies. This is the way that I went with. If you would have done a different way, that's totally cool. There's multiple ways to analyze the same data set. Multiple correct ways, I should say. Multiple bad ways too, but multiple correct ways, or at least defensible ways that you could analyze data. And if you are that sort of a person that is not comfortable analyzing your own data, but you want to be, hey, you've come to the right place. Because I just started teaching online stats classes through simplistics.net. Link in the description. It's my own website. It's pretty cool. So you can take live classes with me, where you get weekly Zoom meetings with me, and I get to answer your questions, and we get to practice things together and that sort of thing. Or you can do it at your own pace via a Canvas course that I have online. And another thing that I just started doing is called office hours. And they're actually pretty amazing. I started it for the first time in October. And how that works is that there's no lesson plan. You just come in with several other students. Currently, I have it limited to 7 students. And we just take turns, different people asking different questions. And it's actually really cool because you get to learn from other people's questions too. And you might be worried, well, what if everybody's more advanced than me? It's actually, what I'm finding is that's not a problem. We had that in our last office hours. And for the people who didn't know what mixed models were, they learned a lot about mixed models just by other people asking questions about mixed models. Kind of gave them a teaser. And because of Christmas and that sort of a thing, it's only going to be 3 weeks, so it's also going to be at a cheaper price during December. So if you are interested in joining office hours, and if you have questions that you want answered by a statistician, me, then please visit simplistics.net to join my office hours class in December. And yeah, and also in January, I'm teaching a mixed models class. So if you're interested in learning about mixed models, I have a live mixed models class coming in January. And I really hope to meet you in those classes because it's fun. Anyway, I hope you've enjoyed this and learned a lot, and I'll see you next time. Peace out.